All right, here's my video for problem 4-94 from the lesson 4.2.4, and this is focusing on the complement of an event. And so you can find the probability of the event happening, and then if you know the probability of it happening, you can find the probability of it not happening by using its complement, or the other way around. You can find the probability of an event not happening and find its complement, saying, okay, now I know the probability that the event will happen. Okay, and I'm going to do part A here using a systematic list and using the complement. So we're saying Crystal is spinning the spinner at the right and claims that she has a good chance of having the spinner land on red at least once in 3 tries. And it's saying, what is the probability that the spinner will land on red at least once out of those 3 tries? So what I'm going to do here is I'm going to make a systematic list of all the things, of all the chances not landing on red. So with A here, one of these combinations that is not going to have a red in it would be yellow, yellow, yellow. That's the event that we have 3 yellows in a row. Another one could be yellow, yellow, blue. That doesn't have a red in it. We could have yellow, blue, blue. We could have blue, yellow, and then yellow. We could have a yellow, then a blue, then a yellow. And just trying to figure out all these different combinations of ones that do not include a red. So we could also have blue, blue, blue. That doesn't have a red in it. We could have blue, blue, yellow. And I believe we can have blue, yellow, blue. These are all the possible combinations of spinning this spinner 3 times and not getting a red. And so there is a 1, 2, 3, 4, 5, 6, 7, 8 events that don't land on a red. Problem 4-94 from lesson 4.2.4, focusing on this complement of an event and this spinner problem to show how we can use the complement to solve for the event happening or the probability of the event not happening. Okay, so in part A, it's saying Crystal is spinning this spinner at the right and claims that she has a good chance that she spins this spinner and it lands on red at least 1 out of 3 times that she spins it. And we're going to look for, okay, then what is the probability that it's going to land on red just 1 time? And so what I'm going to do is kind of use this idea of the complement to solve when is it going to land on red, or when is the probability that it's going to land on red. And so what I'm going to do is actually list all the events where it doesn't land on red. So I'm thinking of all the combinations where I do not have a red involved. And so I'm thinking, okay, 3 spins, it could land on yellow, and then yellow, and then yellow. You see, there's no red there. So that's one of the events where red doesn't happen. It could also be yellow, yellow, blue. There's no red there. It could be yellow, blue, yellow. And it could be blue, yellow, yellow. All those events do not have a red in it. Let's see if we can think of some more combinations that may not have a red in it. So maybe like blue, blue, blue. That doesn't have a red. Maybe blue, 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 yellow. Maybe yellow, blue, blue. And then maybe a blue, yellow, blue. It's supposed to be a Y there, sorry. Okay, so I have, and I think that's it. I can't think of another possible combination that doesn't have a red in it. So there is 1, 2, 3, 4, 5, 6, 7, 8, 8 events where you don't land on a red. Now I've already made this tree diagram representing this situation. And so I can talk about, okay, how many total events are there? Now I ran out of room here at the end, but I can still use the branches to count the total number of events. So this is the branches representing the first event. So it could either be yellow, blue, or red. And then here's the second event where it could branch off of each of them being yellow, blue, or red. And then we actually get a third branch for the third spin. And I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So there's 27 possible outcomes 8 of those outcomes do not have a red. So we can say, okay, 8 out of the possible 27 do not include a red. And so I can use the complement to say, okay, I know how many outcomes do include a red. And the way we use that complement here is to do 1 minus the 8 out of 27. Okay, 1 minus that 8 out of 27 is going to leave me with the remainder of the ones that do include a red. And so I'm going to do my subtraction here, and this 1 could be like 27 out of 27 minus 8 out of 27. And that leaves me with 19 out of 27 options that will include a red. And this is the idea of using a complement. Okay, what you can do is 1 minus the probability of it not happening to find the probability that it does happen. So what they're doing here in the part B then is saying if the probability of event A is represented by PA, so probability of event A happening, how can you symbolically represent the probability of the complement? Well, the complement to PA then, the complement to PA, I can call it the C, equals 1 minus PA. And that complement can be useful in a situation like this where, okay, 8 events of it not happening, that's not that many. But if I had to try to list 19 of the options, that's a lot more. So the complement makes this an easier problem for us, knowing that we can do 1 minus the probability of the event not happening to find the probability that it will happen. You could have also done, if you wanted to say the probability that it's not going to be a red, you could have done 1 minus 19 over 27, and you would have found 8 out of 27 to be the probability of not red. So I know you were having some problems with this. Hopefully this video helps understand how we can use that complement. The big thing is this down here. We represent the complement by this equation or by this formula right here, 1 minus the probability of whatever event. And you can find its complement.